Okay, so today we're really diving deep into the world of Parkinson's research.
Yeah.
Focusing on a company called GeneCode and their work on something called GDNF Mimetics.
Yeah.
Yeah.
And they're really tackling a growing problem.
Right. And when we say growing...
With the numbers expected to double by 2030?
Oh, wow. Double.
Yeah. By 2030, the number of people living with Parkinson's is going to double.
So that really highlights the need for new treatments.
Absolutely.
Especially with the current options being kind of limited.
Yeah, you're right. Yeah.
Current medications like,
Like what's the main one?
levodopa.
Yeah.
They can manage the symptoms, sure, but...
Right. They don't get at the root cause.
No, they don't address that underlying neurodegeneration.
It's like,
It's like putting a bandage on a broken bone,
or like trying to bail out a sinking ship without fixing the hole.
Exactly.
So we're talking about a progressive disease.
Right.
And treatments that just address the symptoms, but not the actual cause.
Yeah, and so where do these GDNF mimetics come into play?
That's where things get really interesting.
Okay.
Our brains, they have this incredible shield called the blood-brain barrier.
Right, we've talked about that before.
Yeah, and it's great. It keeps the harmful stuff out, but it also makes delivering therapies, especially for the brain.
Oh, I see.
Yeah, it makes it really difficult.
It's a double-edged sword.
Exactly.
A real catch-22.
And so you've got GDNF, which is this naturally occurring protein,
Okay.
and it shows some real promise in protecting those dopamine neurons.
Oh, so that's a good thing.
Yeah, but it's just too big.
Too big to do what?
Too big to cross that blood-brain barrier, effectively.
So it's like having the cure, but you can't get it where it needs to go.
It's stuck outside, can't get past the gatekeeper.
So is that where GeneCode comes in? Did they find a way around it?
In a way, yeah, they've developed these, what they call GDNF Mimetics.
GDNF Mimetics, okay.
And they're small molecules.
Small enough to
potentially get past that barrier.
Ah, I see. So they're like...
They're like little keys designed to fit that lock.
Oh, that's clever.
Yeah, delivering that therapeutic benefit right where it's needed.
Right, to the source. So they basically created a smaller version...
A smaller, sneakier version.
...of GDNF. But how do they know it works? What does the research say?
Well, GeneCode's done some preclinical studies.
Okay.
And they're showing that these mimetics, they can protect the dopamine neurons.
In a lab setting?
Yeah, in a lab setting.
So they've seen actual evidence of this?
Oh, yeah.
It's not just theoretical.
That's promising,
That's amazing. And what's even more amazing is that they might not just protect neurons.
Right, that's just part of it.
But potentially encourage growth of new ones.
Yeah, think about that.
Yeah.
Restoring brain function, not just slowing down the decline.
Wow, if that's true, it's a total game changer.
It would change everything.
Instead of managing decline, you're reversing it.
It's a whole new way of thinking about treatment.
And it's not just about the motor symptoms either, right?
Right, Parkinson's is so much more than just the tremors.
Yeah, there's a lot going on.
Sleep disturbances, constipation, mood changes. It's a lot.
It really impacts the whole body.
And if we can restore that balance with dopamine, those non-motor symptoms, they could improve too.
That's really incredible to think about.
It's a holistic approach, treating the whole person.
I like that a lot.
Yeah, it's promising stuff.
So we're talking about possibly halting or even reversing Parkinson's?
Yeah.
Which is huge.
It's a big deal.
I'm sure it's not just as easy as snapping your fingers and it's ready to go.
Oh, absolutely not.
What does that process even look like?
So right now,
Okay.
GeneCode, they're finalizing those animal studies.
Which makes sense.
It's super important before we go into humans.
Got to make sure it's safe.
Exactly.
Safety first.
For sure, for sure.
And then after the animal studies, what's next?
So then it's all about the IND application.
IND?
Yeah, investigational new drug.
Oh, okay.
They submit that to the FDA.
Right, here in the U.S.
Or the European Medicines Agency, depends.
So they can start human trials.
Exactly.
It's a whole process.
Oh yeah, rigorous testing, regulations, the whole 9 yards.
But it's good to know they don't just jump into it.
No, it's very thorough.
And GeneCode's not doing this all alone, are they?
No, not at all.
Because I feel like science is often...
A team effort.
Totally.
Absolutely, collaboration is key.
So who are they working with?
They've got some great partners like ArgoBio. They're helping refine the drug development.
Cool, and who are they?
They're a French startup. Really innovative stuff.
Nice. Anyone else?
And then there's the Neil MacDonald Lab.
Okay.
They're at the Francis Crick Institute in London.
Wow. So it's like a global effort.
It really is. The best minds coming together.
That's amazing. And, assuming everything goes well.
Fingers crossed, right?
Right. The animal studies, the IND, the trials.
Mm-hmm.
What kind of impact could this have? I mean, really?
Okay, so imagine this. Parkinson's treatment, as we know it, It's mostly about managing, right?
Yeah, trying to maintain quality of life.
Exactly. But what if you could slow it down? Like way down.
Or even stop it completely.
That's the dream, right?
Yeah.
And that's what GDNF Mimetics offer.
Instead of just trying to hold back the tide.
You're changing the tide itself.
Wow. That's powerful.
This whole new world of possibilities, you know?
It really is, and I think it speaks to
what?
to this change in medicine, like we're understanding the brain more and more.
Oh, absolutely.
And with that comes these amazing new treatments.
It's an exciting time, for sure.
Who knows what breakthroughs are next, you know?
Right. It's like the tip of the iceberg.
Exactly.
And there's one more thing about GeneCode's research.
Oh.
It goes beyond just Parkinson's.
Now you've got me really interested. Tell me more. So you're saying GDNF Mimetics could go beyond Parkinson's.
Yeah, it's not just about Parkinson's.
That's really interesting.
We've been talking about it in that context, but remember the main thing.
The neuron protect.
And the growth.
Right.
That has implications for, well,
a lot of things.
A whole range of neurological conditions, really.
So like what? What are we talking about here?
Well, you've got Alzheimer's, ALS.
Oh, wow, okay.
Potentially even spinal cord injuries.
Things that are really difficult to treat right now.
Exactly. And those are just a few examples.
So GeneCode is focusing on Parkinson's now, but...
It's more like a starting point.
Right, because this technology...
It could have much wider applications.
It's like,
What's a good analogy?
I don't know, it's like discovering a new element or something.
Yeah, like on the periodic table.
And it has all these uses you haven't even discovered yet.
Exactly. You start with one thing.
But it has this huge potential.
And that's how it often goes with scientific progress, you know.
You just never know what you're going to find.
You start looking for one answer, you find something else entirely.
And it opens up these doors.
Leads to even bigger questions.
Like, what if we could protect and regenerate our brains?
Think about what that could mean.
It's pretty mind-blowing.
It really is, and that's what makes this research so exciting, you know.
It really is.
It's pushing the boundaries.
And it all started with this deep dive into one company.
And look where we are now.
Yeah, it's incredible to think about all the possibilities for the future of, you know, brain health.
Absolutely, and thank you all for joining us on this journey into the world of GDNF Mimetics.
It's been a fascinating deep dive.
We've just scratched the surface, really.
But it's clear that this field is just bursting with potential.
And who knows what breakthroughs are coming next.
Exactly. Thanks for listening, everyone.